My name is Eveline Killian, and I'm an architectural engineer in Burlington, Vermont for CX Associates. We are an engineering consulting firm that performs energy analyses, and we work on existing and new commercial buildings to optimize their energy efficiency while maintaining comfort. We've been working with Main Street Landing on optimizing and improving the efficiency of the Lakin College building for a number of years. And in this presentation, we will discuss this energy efficiency work and the modifications we made to respond to the COVID pandemic in 2020. First off, let me explain the building a little from the viewpoint of an evaluating engineer. The building is a 87,400 square foot building, 3 stories, and it was built in 2005. Over 80% of the building is office or retail space, 4% is restaurant, and 14% is performing arts, theaters, and event spaces. From its inception, Main Street Landing has been committed to sustainability and energy efficiency. Its 2005 design was certified by the Leadership in Energy and Environmental Design, or LEED. Lakin College was also one of the first participants to sign up for the Burlington 2030 District in 2017. The 2030 District is a national private-public partnership working to reduce building energy consumption, water use, and transportation emissions by 50% by 2030. Burlington is the 17th city to join this national network, which includes such cities as Seattle, San Francisco, Denver, Austin, and Pittsburgh. To date, more than 250 Burlington buildings representing almost 10 million square feet have signed on to this pledge. CX Associates is the technical engineering resource for Burlington 2030, and we evaluate buildings to develop their energy efficiency goals, track their energy consumption, and assist in energy reduction implementation projects. The first step in the program is to evaluate how this building performs compared to other buildings of its type. When Main Street Landing joined the 2030 District in 2017, we compared the building to a national average baseline for an office building type in this climate zone. This baseline energy consumption is 115,000 BTU per square foot per year. In 2017, we evaluated Main Street Landing's energy consumption to be 95,000 BTU per square foot per year, or almost 20% less than the national average. In 2019, we evaluated the building again, and its energy consumption was 80,000 BTU per square foot per year, 16% less energy use than when it joined the district in 2017, and more than 30% lower than the baseline office building for this climate zone. The 2030 district's program goal is to be 20% less than the district baseline consumption by 2020, 35% less by 2025, and 50% less by 2030. As you can see, this building is well on its way to meeting this goal early. So next, I'd like to dive into how we attained this 16% energy reduction between 2017 and 2019. In 2018, we went through a retro commissioning project where we implemented a number of measures. We upgraded the building automation system, which improved equipment controls as well as equipment operation oversight. We optimized the central plant control sequences. We installed LED lighting, and we modified the common area and event spaces mechanical systems schedules and set points. As an example of this last one, the event spaces, for these spaces, the new automated control system enabled the event coordinator to set space temperatures to the schedule of the events rather than holding the space at a comfort level during unoccupied hours. Additionally, we enabled the event coordinator to program the event space temperature separately from the ventilation. The temperatures are now set to a comfortable level a few hours prior to an event or when a few people are setting up the space. But we don't increase the ventilation until the event is scheduled to start and people are actually gathering in the space. This saves considerable amount of energy. There are also many small control sequence changes to the boilers, the chiller plant, the pumps, and the fans, which optimize temperature and pressure set points according to the outside air temperature or interaction with downstream components. Altogether, these tweaks added up to the considerable energy savings we saw in the 2030 district energy analysis. And then, March 2020, everything changed. The pandemic hit Burlington and Vermont and the country and the world, and we all went into lockdown. Offices, restaurants, and theaters closed. A skeleton crew occupied the building in various offices and in the restaurant, but most of the building was empty. And naturally, all of the events stopped. After we all took a long pause to catch up to what had happened, we started discussions with Main Street Landing in about mid-May of 2020 to determine the best measures that we could take to enable them to open up retail and office spaces to some capacity safely. Early in the pandemic, the industry confirmed that mechanical ventilation could play a role in mitigating the spread of the virus, and that its greatest impact was on reducing the presence of long-range aerosols. The masks and social distancing kept the short-range aerosols and droplets from spreading the disease, but mechanical ventilation and filtration could clean and dilute the air. So in early June, we implemented the following measures. The first thing we did was to increase the ventilation air from 30% to 60%. This is more than the industry standard requires for fully occupied spaces, and our spaces were never planned on being fully occupied. As a side note, the industry standard we are referring to is the ASHRAE Ventilation Standard 62.1. Next, we programmed fans to run at a maximum speed during occupied hours and 2 hours before and after occupied hours so as to purge the spaces. Then we programmed the air handler fans to operate at minimum speed the remainder of the hours, so during unoccupied hours, so that there is continual air movement and air changes. To augment that, we programmed the exhaust fans in common spaces to operate 24/7, which increases the overall air coming in throughout the building. We also programmed any systems that modulate ventilation air, so outside air, based on the space's carbon dioxide levels, which is a measurement of occupancy, to operate with more ventilation by decreasing the set point of that control from 1,200 parts per million to 800 parts per million. This basically ensures that when there is occupancy of any kind, the air handling unit's outside air dampers will open up. Then Main Street Landing also urged the tenants to open the windows if the outside air temperatures were conducive to do so, which in Vermont was the case until probably late October, early November. At the same time, we ensured air intakes and energy recovery wheels were cleaned to make sure that the outside air was getting into the building properly. And we ensured that the housing of the air handler filters and energy wheels were well sealed inside the air handling units so that the air doesn't bypass the filter mediums. We further installed MERV 13 filters in the return ductwork, and to raise the building relative humidity levels, we increased the cooling space temperature from 72 to 74 degrees. To reduce energy consumption, we decreased the heating set point in the event spaces, which were empty, from 70 to 65 degrees. Additionally, tenants purchased their own standalone HEPA filters when they wished. HEPA filters are the only type of filter that will actually capture the long-range aerosol-sized particles. Because Main Street Landing is concerned about energy consumption, CX Associates analyzed the energy impact of both the immediate shutdown, when the building had not implemented the indoor air quality measures, and there were very few people in the building at all, so springtime 2020, and the impact of the indoor air quality measures we implemented when people started working in offices again under what I'm calling the new pandemic normal. So this analysis, the immediate impact of the shutdown, when everything pretty much came to a grinding halt and the building was virtually unoccupied, but the COVID measures had not been implemented yet. The natural gas consumption went down 28% and the electricity consumption went down 37%. This is enormous, and it's driven by the reduction or the removal of music and events and cooking and air conditioning and heating and lighting and plug load uses. And though it is good for the planet not to use this energy, it's not good for our economy or our well-being, and it's not sustainable. The next line on this table shows the impact of operating under the new pandemic normal. This includes not having events and definitely includes smaller lighting and plug load usage, but it also includes increased ventilation and filtration, comfortable space temperatures in more occupied areas, and a limited occupancy of offices, restaurants, and retail. The intent of all this was for a safer operating paradigm meant to sustain businesses through the pandemic. The impact when looking at an entire year of operating, so expanded to look at an entire year of operating under this new pandemic normal, is shown in the second row. And it is a decrease of 1% in natural gas and 8% in electric consumption over non-pandemic normals. We calculated these values by extrapolating the September through December impact across all heating months of a year and used the summer impact that we saw in the June through August period for the cooling months of the year. All of that data was normalized to 2019 weather conditions. I do want to caution us here. The very low energy impact of the measures we implemented for COVID are due to the changes we made and the low occupancy and the lack of events. If we maintain these pandemic sequences when we go back to our much anticipated operating mode of full occupancy and music and plays and weddings, etc., the energy impacts of maintaining the set points of doubled outside air and increased fan speeds for many more hours will be very high. So when we get back to our real normal, it will be our job to ensure the building returns to its optimized operation we had implemented in the 2018 retro commissioning project. With that in mind, and because it would be a shame to have lost all of the efficient programming of the mechanical equipment we developed, the controls programmer from Temperature Controls of Vermont developed the pandemic sequences under a new mode, and we implemented a pandemic mode button on the controls interface so that the building operator can easily go between the efficient mode and the pandemic mode of control sequences. Hopefully we won't need this for future pandemics or epidemics, but it's there if we do, and we don't have to recreate it or the efficient operation. So since at the time of this recording, we are still in the pandemic and things are still closed, I will leave this slide as the last one in this presentation and hope that it soon comes to fruition that these images reflect our normal lives again. We look forward to using this building the way it was designed and the way that we know that Main Street Landing will again be a sustainable, efficient, and vibrant icon on the Burlington waterfront. I hope this was informative about the good things happening behind the scenes at Main Street Landing. If you have any questions about this presentation, please don't hesitate to contact Main Street Landing or CX Associates. Thank you.